Hi guys! Today I'm going to go over questions 1 through 15 of the 2016 AMC 8. Timestamps to each individual problem will be included in the description. So without much further ado, let's math. Question 21 states, a top hat contains 3 red chips and 2 green chips. Chips are drawn randomly, one at a time without replacement until all 3 of the reds are drawn or until both green chips are drawn. What is the probability that the 3 reds are drawn? Okay, so let's see. Let's underline some important facts. 3 red chips and 2 green chips. So we want to find the probability that 3 reds are drawn. In my opinion, the best way to go about this question would be through casework. So what do I mean by that? Well, let's think about all of the cases where the game could end. The game could end if there are 0 green chips drawn and all 3 red chips are drawn. The game could end if 1 green chip is drawn and 3 red chips are drawn. The game could end, and this is the final case, if 2 green chips are drawn and 1 or 2 red chips are drawn. Sorry, I lied. I sort of lied. It's not the final case. It's sort of a big overarching case with 2 subsets, essentially. So let's think about these 3 cases. So first of all, 0 green chips. There is one way to do this. That would be R, R, R. So 1. The second case, 1 green chip. Okay, so the total amount of ways to do this, and let's just count this out to make sure that we're really counting all of the ways that this game could end. It would be G, R, 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 G, R, 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 G, R. Now you may be wondering, why not R, 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 G? That wouldn't make sense. The game would end right here before we even got the chance to draw this green chip. So that is why that case would not be included in this. Or sorry, you didn't see that. In this. Okay. So the third and final-ish case would be 2 greens. So what are the ways to do this? First of all, right off the bat, 2 greens immediately drawn. Green, red, green, green, red, red, green, red, green, green, red, green, red, green, red, red, green, green. Again, you can't have green, red, red, green, red, because then the game would end right here and you wouldn't get a chance to draw this red one. So that's something to be wary of when you're solving these sorts of questions. So the probability that the 3 reds are drawn. Oh, sorry. Let's total up these cases. 3 cases for case 2, and 1, 2, 3, 4, 5, 6 cases for case 3. Sorry, 6 outcomes. Okay. So the probability that the 3 reds are drawn would be, the probability that the 3 reds are drawn would be cases 1 plus cases 2 over cases 1 plus 2 plus 3, because this, the numerator, would be all of the possible cases that the game could end, and these would be the possible cases where the game ends because of the reds instead of the greens. So, because we already counted all these cases, this becomes easy. Case 1 plus case 2, 1 plus 3 over 1 plus 3 plus 6, that equals 4 over 10, that equals 2 over 5, which is answer choice B. Question 22 states, Rectangle DEFA below is a 3x4 rectangle with DC equals CB equals BA. What is the area of the bat wings, or the shaded area? Okay, so we can assume that this factor is in scale, and we can see that DE would equal 4, similarly AF would equal 4, EF would equal 3, and DC will equal 1, CB equals 1, BA equals 1, because DC equals CB equals BA. So, what is the area of the bat wings? So the bat wings, this area would equal the area of rectangle DEFA minus triangle ABF minus triangle CDE minus triangle BC, and let's label this O, so BCO, minus OEF. Okay, so we can find DEFA easily. It's just 12. Base times height, length times width. It wouldn't be base times height, I'm sorry, it would be length times width. So 3 times 4 equals 12. ABF, again, pretty easily. 1/2 times base times height, that would be 2. Because height, base, again, height, base, that would be 2. So what's a little trickier to see is that BCO and EFO are similar. This length and this length would also be in a ratio of 1 to 3. So let's label this X. Let's label this 3X. How do we know that? Because, let's say we don't know that yet. Let's say this is Y. So the area, or the length of the base is for triangle BCO is 1, and the length of the base for triangle EFO is 3. So that would mean the lengths are in a ratio of 1 to 3, and that would equal X over Y. So that would, so that would equal Y equals 3X. So this would equal 3X. But what else do we know about this entire length? Well, that entire length equals 4. So we know that 3x plus x would equal 4. So we know 4x equals 4, so x equals 1. That will mean this height is 3, and this height is 1. So we can now extrapolate the areas of BCO and EFO. So BCO would equal 1/2 times base, which is 1, times height, which is 1, so that would equal 1/2. This would equal 1/2 times base, which is 3, times height, which is 3, that would equal 9/2. So let's erase some of the more messy parts here. And all we have to do now is subtract to find the area of the bat wings. So let's do this in white now. I like white. So the bat wings, or the area of the bat wings, would equal 12 minus 2 minus 2 minus 1/2 minus 9/2. So that would equal 12 minus 2, 10, 10 minus 2, 8, 8 minus 1/2, 7, 1/2. This minus that would equal, what am I thinking? 3. So the area of the bat wings is 3, and the answer is C. Question 23 states, 2 congruent circles centered at points A and B each pass through the other circle's center. The line containing both A and B is extended to intersect the circles at points C and D. The circles intersect at the 2 points, one of which is E. What is the degree measure of angle CED? So let's draw a diagram of this problem. So two congruent circles. Let's say that's a circle. That looks kind of like a circle. Centered at points A. Let's say this is point A. And another congruent circle. And they both pass through the other circle center. So this would be like this. And right here, that would be B. Let's make that A a little darker. Okay. So the line containing both A and B is extended to intersect the circles at points C and D. So this would be C, this would be D. And they also intersect at 2 points, one of which is E. So let's say this is E. What is the degree measure of angle CED? Okay, so first of all, let's do this. Let's draw in yellow AE and BE. So what do we have now? AE is a radius of circle A, so it's congruent to BE, which is a radius of circle B. AB is a radius of both circle A and B, so all three lengths are congruent to each other, making this a, what is it? A equilateral triangle. Sorry, I blinked for a second. So the angle measure here would be 60, 60, and 60. So looking at this, what can we do now? Well, first of all, let's talk about lengths. Let's say that this length is 2, and let's drop a perpendicular right here. So this length would also be 2, and this length would be 1. So what do we have here? This length would be, think about it for a second, 1 squared plus, let's say this is x. X squared equals 2 squared. 1 plus x squared plus 4. X squared, no, sorry, not plus. It would be equals 4. Equals 4 equals 3. X equals root 3. X equals root 3. Okay, let's just write that. So this is the Pythagorean theorem, if that wasn't clear. Okay, so now we know that that length is root 3. We can now see that CE would be, sort of similar. Like, okay, first of all, let's label this point. Let's label it O. We can see a special triangle here. A special triangle right here. Triangle COE. So let's extricate that and sort of just draw it freehand. That's really messy, oh gosh. Let's sort of draw it like this. So it would be 3 root, 3 root 3. So let's calculate this length. That would be 9 plus 3 equal y squared. So this would be 12. So y equals 2 root 3. 2 root 3. So what do we see here? We can see that triangle COE is a 30, 60, 90 triangle with C equaling 30 degrees and OE equaling 60 degrees. So we can gather that this length, right, that's not that visible. Let's do this color. This angle right here would be 60 degrees. 60 degrees. So by symmetry, or if you want, you can just do the whole thing over again for triangle DOE and see that that too is 60 degrees. So now we can just add angle CEO and DEO to get angle CED, which equals 120 degrees. So answer choice C. Question 24 states, the digits 1, 2, 3, 4, and 5 are each used once to write a 5-digit number PQRST. The 3-digit number PQR is divisible by 4. The 3-digit number QRS is divisible by 5, and the 3-digit number RST is divisible by 3. What is P? Okay, so first of all, let's write down the information we got and try to extrapolate some extra information from those facts. Okay, so digits 1, 2, 3, 4, 5 used to write a 5-digit number, or PQRST. 1, 2, 3, 4, 5. Okay, so we know that this is true, this also true, and this is true. So basically what I've written here is all the information given right there. That's a little messy, I'm sorry. Okay, so from this, we can first get that S must equal 0 or 5 because it's the last digit and it's divisible by 5. However, 0 is not one of the options that we have up here. So we can cross that off and know that S equals 5. So PQR5T. Now let's look at, this wouldn't be 3, this would be 4. Let's look at this piece of information. So what we can get from this is that QR is divisible by 4. QR is divisible by 4. So cases where that would work would be when R is equal to 2 or 4. Because with any other number, it would not even be a multiple of 2. So let's do some casework here. First case, when R equals 2. Okay, let's say R equals 2. Then we can see that using this last piece of information, RST would equal 2, 5T. And 2 plus 5 plus T would have to be divisible by 3 for this to be correct, or to be correct. But there is no way that we can plug in a value of what's left of our 5 numbers, which let me write that down. 1, 2, 3, 4, 5. We've used 5, we've used 2. We can't plug in 3, we can't plug in 1, and we can't plug in 4 to make this work. So case 1 is incorrect. So now let's go to case 2, where R equals 4. So that would mean 2, 4T would be divisible by 3, making 2 plus 4 plus T divisible by 3. This could work in the case where T is 3. So that would mean R equals 4, S equals 5, and T equals 3. So now the only digits we have left are 1 and 4. We need to see where we can plug those in. So let me erase a little bit of the mess over here to make room for some more math. Okay, that's basically a repeat. I'll just circle 1 and 4. Okay, so we need to know which one of these is P. So what do we do now? Well, let's write PQ 4, 5, 3. We can now use this. The fact that PQ4 is divisible by 4. That will mean Q4 has to be divisible by 4. The only way for this to work is if Q equals 4, because if Q equals 1, 14 is not divisible by 4. So Q must equal 4, which means that P must equal 1. So that means P is 1. Answer choice A. Question 25 states, a semicircle is inscribed in an isosceles triangle with base 16 and height 15, so that the diameter of the triangle is contained in the base of the triangle as shown. What is the radius of the semicircle? Okay, so first of all, let's draw the height, since that's one of the lengths that were given. So let's draw that height, and that equals 15. And the height, because this is an isosceles triangle, the height evenly splits the base into 2 equal parts. So this length right here would equal 8. This also equals 8. So using the Pythagorean theorem, we can see that, let's label this x first. Let's label this a actually. 8 squared plus 15 squared would equal 8 squared. So 64 plus 225 would equal a squared. This would equal to 89, which would equal a squared. So a, because it can't be negative, would equal 17. So a 17. Okay, now what can we do? So now what can we do to solve this problem? Well, one thing we can do is draw a tangent from the center of the semicircle to one of the sides. So basically what I'm saying is that this is the center of the triangle, so we can draw a tangent from there like this, where it hits the side, it creates a perpendicular. So now what we can do is we can label this x, and x would be the radius of the semicircle. So how do we find x? Well, we can use area. The area of this triangle, this sort of like, you know what? This like half triangle right here. That triangle, that right triangle, the area of that triangle would be 15 times 8 over 2. It would also be, because x is an altitude to 17, it would also be x times 17 over 2. So multiply both sides by 2, 15 times 8 equals 17x. So this would equal 120 equals 17x. So 120 over 17 equals x. And since x is the radius of the semicircle, the radius of the semicircle equals b. Thank you guys so much for watching. Stay tuned and subscribe for more math content and explanation of AMCA problems.